Meteorology Lab students, welcome back. Let's start looking at fronts. Now, we're not really going to review too much about individual fronts, cold fronts, warm fronts, occluded fronts, dry lines. Hopefully that's all information that you have from lecture class. The handout does a little bit of that. What I wanted to do was eventually go through this example here from your lab, your practice lab. Even though you have the answer key to this, I wanted to kind of show you how you go about figuring out where the fronts are on this. And we're going to do this by evaluating the synoptic weather symbols here. So what I want to do is, we're going to come back to this. What I wanted to do is just sort of show you, first off, what a typical low pressure storm system looks like with fronts and some of the conditions we associate with those fronts. And then we can start thinking in terms of how that's going to be represented with our synoptic weather symbols and how we can eventually use that to find fronts on a weather map. So here we have a low pressure system, and I'm just going to draw a generic standard low pressure system with a cold front and a warm front. Want to emphasize that any individual front system, low pressure system that you come across on a weather map might look very different than what I'm going to draw. I'm just drawing a stereotypical one that you might see somewhere across the US. So with our low here, we might very well have a cold front. I'm using blue for my cold front. Again, you can use black and white, it's fine. You don't need to use color. You can if you want, that's great. And I will post some of these blank images here if you want to kind of play along at home as I'm doing this. You can kind of just follow along or just follow along with the PowerPoint in this video. Alright, so there we have our cold front. Let's draw just some generic warm front on here. Again, it might have some weird shade. Remember, warm fronts, we have the semicircles. For warm fronts, cold fronts, we have the triangles. And again, I'm using color here, but using black and white is fine as well. That's why we have the symbols. Alright, so here we have a low pressure system with a cold front and a warm front on some sort of map. But what we want to think about is, what are the conditions like ahead of and behind these fronts? Or there's another way to kind of think about it is there's kind of three distinct areas on this map. We have this area here ahead of the cold front. We have this area between the warm front and cold front. And we have this area here behind the cold front. And so we want to think about what are the conditions in each of these sort of zones or areas in terms of a variety of weather conditions, not just one. Well, one of the good ones to start with are going to be the wind directions. And in general, and again, I'm greatly generalizing here, but in general, certainly with a setup like we see here, our winds behind the cold front are generally going to be coming like this. So, generally speaking, with a cold front like this, the winds behind the cold front generally coming anywhere from kind of north to west. In this example, northwest. That's a pretty typical wind direction behind a cold front. The air here is going to be, oddly enough, cold. Now, I say this a lot in class and in lab. A lot of times when we use the terms warm or cold, those are relative terms, meaning it is colder here than, say, the air that's here. This may or may not be cold by your standards, but it is colder than the air that's here. So the air ahead of the cold front is going to be intrinsically warmer. Now, the wind here with our, what we call the warm sector, can, again, generically it can come from a wide range of directions, but generally southerly type direction. It might be southwest, it might be southeast, it might be south, but generally a southerly direction. And in this example, the winds would probably be coming something like this. So in this example, kind of a southwest wind. Again, a different warm front, different setup. It might be more south. It might even be a little bit southeast, but generally from the south. And so what we see then is along our cold front here, we have about a 90-degree change in wind direction. The head of the front, generally southwest. Behind the front, the winds are going to shift and come out of the northwest. Now, in front of our cold front, in front of our warm front, we're going to find the air generally cooler than the warm air here. And again, the winds are generally going to come out of the east. They might be a little southeast, they might be a little northeast, just depends on the front, but generally kind of out from the east here. So probably in this scenario, we've probably got a little east-southeast flow kind of going along here, maybe even a little northeast-northeast flow like this. But generally out of the east here. And again, it might be southeast, it might be northeast, but generally kind of out of the east. And so what we'll see is a general about 90-degree change in wind direction from one side of the warm front to the other side of the warm front. And that's, again, just about a 90-degree change in wind direction. Now, let's go back to it a second. Remember that with a low pressure system in the northern hemisphere, and this is a northern hemisphere example, we expect a counterclockwise rotation with our winds into the center of the low. And that's what we have. Overall, we see the winds are going counterclockwise here. There's an overall counterclockwise rotation with this. It's not maybe quite as smooth as we've drawn it before, because what we're going to find is it has these distinct changes in wind direction. But the overall flow is still counterclockwise. So we haven't broken that rule that we talked about, or that bit of information that we relayed earlier in the class. So if we were to think about some weather symbols here would be showing overall that kind of wind coming from the northwest. And here we'd expect our weather symbols to be showing overall wind coming from, again, the southwest. And here we'd expect our winds to be coming out of, generally speaking, kind of out of the east to the northeast, just depending on exactly where you're at. And again, I've just put some generic wind markers there in terms of wind speed, anywhere from 5 to 15 knots. Don't read too much into that. But we're just looking at, again, the changes in our wind direction with our wind symbols. Okay? We'd expect warmer temperatures here than we would expect here. We'd expect warmer temperatures here, significantly warmer temperatures than we're going to see here behind our cold front. The bigger the difference in temperature, the stronger the front is. When we talk about a strong front or a weak front coming through, that often relates to that temperature difference across the front. Big difference in temperature generally means you have a very strong front coming through. That's going to relate to a very strong change in density from one side of the front to the other. That implies how much lifting you're going to have. Lifting, of course, implies how many clouds and storms and all that you're going to get out of that front system. Weak fronts tend to have smaller temperature differences between them. Not as strong of a density difference, not as strong as lifting. So those are some of the terms we use to describe, in some cases, the strength of our fronts, again, all related to that temperature difference. So this is a pretty generic example of a low pressure system with some weather fronts, a cold front and a warm front, and then our weather symbols just to show a little bit about those. Okay, what I want to do next is kind of almost go backwards from this and start with our weather symbols and kind of see where our fronts fit in with all that. let me just quickly get rid of this. All right, so in this example, we're going to have, again, another low pressure system. And these little circles are going to be our synoptic weather symbols. And we're going to put in just some random generic ones here and see if we can't figure out where our cold front and where our warm front might be. So let's say we had, again, I'm just going to draw on some random ones here. Don't read too much into the exact values that I'm putting in here, but just we're going to be looking at the overall trends here. So a 15-knot wind, northwest, 45 degrees. This one, let's just say it's 42. 5-knot wind. This one, let's say, is 38 degrees. 10-knot wind. Let's say this is going to be 5-knot wind. Let's just call this 46 degrees. Again, I'm just sort of making up the temperature numbers here. Here, let's put a nice little southwest wind, 5 knots. Let's call this 65 degrees. Here, let's call this 69. 10-knot wind. This one, 70 degrees. 5 knots. 71 degrees. 10 knots. 5-knot east wind here. We'll give this, let's call this 55 degrees. 52 degrees here. Give that a 10-knot wind, again, kind of east-northeast there. And let's give this one a 50-degree 5-knot wind, again, almost out of the east. So if this is what we're given, let's just say for an example, what I might do, if it was me, I might take my pencil. This is what I often do when I'm looking at this kind of data, is I'll start with a pencil so I can erase it, and I'll look at the general wind directions. I often start with wind because it can often be a very strong indicator of where the fronts are. Not perfect. You don't want to rely on any one station to tell you where the front is. You want to look at the overall trend in an area with the wind. And what we see here is a general kind of northwest, north-northwest, west-northwest kind of wind. So overall, the wind's kind of coming in like this. Here, hopefully you can see that. Hopefully it's not too faint for you in the green here. I see a very distinct wind direction here compared to here. It looks like these winds are generally kind of coming in like this. Again, generally kind of east-northeast. These winds here, generally coming kind of a southwest direction. Okay? And so we can start to see then 3 distinct areas of wind. Are they all perfectly parallel? No. There's going to be local variations in topography and things like that that can curve winds, but overall we see the general trend of these distinct directions in wind. With that, we also have temperature data. Notice here it's generally 60s to low 70s. Here, lower, we're looking at 50s here. Here we're looking at 40s and 30s. Okay? So based on, in this case, just sort of generic wind and temperature data, I'm fairly confident that we've got some sort of cold front coming through here. Because we have that northwest wind, colder temperatures, southwest wind, warmer temperatures here. Classic cold front. Now, what we may find too is we may find, in addition to all this, other information that makes sense. You know, maybe we're going to find a lot of cloud cover along our front here. And maybe we'll see some precipitation symbols with this as well. Just drawing in some dots, again, indicating rain along that front. So that's other information you can use. Cloud cover. Is the cloud cover near the front, like you'd expect with a cold front? Is it a little bit further away from the front, like you'd expect with a warm front? What kind of precipitation? If it's above freezing, do you have rain? If it's below freezing, do you have snow? Those are also bits of information you can use to help determine exactly where that front is. You can really kind of narrow it down. So again, we've got 60-degree temperatures, 70-degree temperatures here. We've got temperatures in the 50s here. So probably have some sort of warm front here. So it looks a lot like the other front system that we used, but in this case we went about it by looking at what our synoptic weather data was telling us. And the synoptic weather data, again, really pinpointed where these fronts should be, right? Let me give you an example of how this wouldn't work, right? You really couldn't put the cold front through here because these wind directions are all similar and the temperatures are fairly close. Right? There's not a big enough change in temperature between those two locations. But again, between here and here, you've got distinct changes in wind direction, distinct changes in temperature, distinct changes in clouds, you've got precipitation. All of that goes in to help you pinpoint where that front is. So like I said, I often start with wind, but don't let wind be the only decider that you're using. You've got wind, you've got temperature, you've got weather conditions, you've got cloud cover. You've got past weather conditions. You've got how long ago it's been, raining or precipitating. You've got cloud types, cloud levels that you can look at as well. Like a lot of detailed information, especially with warm fronts, can really help pinpoint exactly where that front is. So a lot of information in those synoptic weather symbols that can help you pinpoint those fronts. But like I said, I always start with wind. It's a good place for me to kind of at least start to narrow down where I think those fronts should be. All right, so let me jump to the example from the practice lab, and I'll kind of run you through how I would approach doing that one. Again, you have the answers, you have the key to help you figure these things out. I kind of just want to run through that with you just to kind of show you how I would go about doing this one. So this is this first one again from your practice lab. We have our low pressure here. We've got the weather symbols here. Now one thing I will just say, you see the A and B and C and D. That's just labeling those. That doesn't mean anything. That's not weather data. That just means that's A, that's B, that's C, that's D, that's E, that's F. So we can use those to identify which one we're talking about. But it's not actual data, so just ignore the letters that you see there in terms of trying to show you any data. So again, the first thing I'm going to do is I'm going to start looking at my winds. And so I see, okay, I've got some winds here that look kind of similar, right? They're all kind of generally kind of out of the west. I've got some winds here kind of coming out of the east. It looks like I got some winds here kind of coming out of the southwest. So again, if my green marker was my pencil, I would just put some light little arrows kind of like that. I've got some winds like that here maybe. And it looks like I have some winds kind of like that there. Okay. All right, good place to start. Now let's look at things like temperature. We've got 64 here, we've got 55, 55. And between here and here, I go from 55 to 45. That's a pretty big jump in temperature. Again, 64 here, 47 here. Pretty big change in temperature. Let's look at cloud cover. I've got overcast skies here. I've got rain, overcast skies here, rain, partly cloudy here, 4/8 here, 2/8 here. All right, that's interesting to note. Distinct change in wind direction, almost 90-degree change in wind direction that we've got from some of these locations here. But again, changes in temperature as well. So I'm thinking, based on what we have here, that we've got a cold front, not a terribly strong one, going just about through like this. Behind it, we have the cloudiness right near the front. We've got the precipitation right near the front. It's interesting to note, too, these two wind directions here aren't that different. They're not quite as big of a difference as we've seen in some of the other examples. So that's where I said before, don't let one station of wind throw you, right? That wind direction may go, oh, maybe it's maybe it's on the other side of the cold front. The temperature tells you that it's not. Right? Temperature says this has got to be in the warm side of your cold front. You know that the wind direction is not that dissimilar to this one here. That's okay, because you've got the temperature to back you up on that. So that tells me that cold front is somewhere between these two. Let's see if we have a warm front. Maybe we do, maybe we don't. Sometimes you do, sometimes you don't. Again, we've got 36 degrees here. We've got 55 degrees here, 33 here, 55 here. We've got that distinct change in wind direction. We've got completely overcast skies here, some showers occurring. That's fun. Showers at 36 degrees Fahrenheit. That's great weather. Again, 4/8 cloud cover here. So I'm thinking based on the cloud cover, precipitation, temperature changes, and the wind direction, we've got a warm front in through here somewhere. And in this case, the warm front's fairly strong. The temperature difference is fairly big, pretty much bigger than our cold front. So we probably have a somewhat weak cold front here with a fairly strong warm front in this particular setup. So again, notice I start with the winds, and then I look at that other data to kind of back me up and say, does it make sense where this front is? What other data can I use to really narrow down where that front goes? So again, don't just rely on one bit of data. Use all the data you have available to you to help you pinpoint where you think those fronts are going to be. One last thing I want to cover before I let you go. Now this is to go back to our generic sort of example of a front. And just throw one more little twist in this for you guys. So if we start off with some sort of cold front, like this, let's throw the warm front here. What I want to look at with this example is sort of your standard low pressure system with fronts, but also look at what we call a dry line. And a dry line is a is a front not based just on temperature, but the dominant change here with that front is the changes in humidity. So we have two broad types of fronts: temperature fronts and humidity fronts. Cold fronts, warm fronts, or temperature fronts. Dry lines are humidity fronts. And so what you might see on your weather map like this, I'm going to focus in on this area here, which is typically where you're going to find a dry line in a map like this, is let's say you have your weather symbol here, got a wind direction indicator. What you really want to start looking for dry lines is the difference between your temperature and your dew point. So I've got 60 degrees Fahrenheit for temperature, 5 degrees for dew point. Let's say I've got another one here. Let's say this is 62 and 3 degrees. So 62 degrees Fahrenheit, 3 degree dew point. That's a pretty big dew point spread, the difference between temperature and dew point. Whereas this one here maybe is going to be 42 degrees temperature with a 40 degree dew point. And over here, we've got, let's say 68 degrees with a 60 degree dew point. And another one here, 70 degrees temperature, let's just say 64 degree dew point. So overall, we've got this somewhat similar wind direction, but the big difference that we see between these ones here really is this huge change in temperature and dew point here. This air, while somewhat similar in temperature to this one, is much, much, much drier. And so very likely there is a dry line or dry front between these here and these here. And we're going to draw a dry line. Ideally, you use sort of it's kind of a yellowish brown color. I've only got brown available with my markers. But we would draw in a line like this, and we draw these semicircles. We don't color them in. We draw them right next to each other. Okay. And that tells me that this air coming in from here is distinctly drier than the air sort of coming in from here. And very different than the air coming in from here. Okay, so that would be a dry line. So this line here is your dry line. Very dry air here, still relatively warm, but dry air compared to the air here, which is warm, but much more humid. So that's the difference right in there. So there's one of the questions that asks you to try to identify the dry line. And so you want to, again, look at that temperature dew point spread to figure out where the dry line is. All right. Hope that helps identify where fronts are based on synoptic weather symbols. There was a reason why we spent so much time on synoptic weather symbols, because again, it's going to help us with identifying fronts. We also use meteograms. And if you remember back when we were doing the meteogram lab, one thing I emphasized a lot was the changes that you see in the meteogram. And we can use these same changes here, right? As the cold front passes, you should expect about a 90-degree change in wind direction. Winds from one side of the front to the other should go from roughly south-southeast to roughly west to northwest, right? So you should see those changes in the meteograms as well. So anyway, like I said, I hope this helps. Any questions, let me know. Otherwise, stay safe and I'll see you next time.